Okay, so now we're going to look at abstract ways of creating landforms. In this case, using these field components, you can see that we have point charges, spin forces, a line charge. When we start to combine these different forces and fields, we can start to create some really interesting landforms. So there's a lot of different outputs that can come from this. There's a lot of different methods. So it's a really, in my opinion, fun way to create landforms. You can spend quite a bit of time really creating some unique features. So what you want to do is, in this case, start with a surface. So I'm going to create a surface that's 100 feet by 50 feet. Let's change this to shaded. And now we will reference this surface into grasshopper. Let's go ahead and hide this. So from this, we want to create a grid of points. And again, there's all sorts of different ways to create a grid. We're just going to start with the conventional way of dividing the surface by a grid of points. If you want to keep them nice and uniform, you have to know that there's a certain quantity in the U count or the X direction, as well as the V count or Y direction. And if you want these to be perfectly squared grids, you have to know that in this case, when I have a proportion of 2 to 1, since it's 100 by 50, I want to double the U count compared to the V count. So let's start off with something like 30. So I'm going to drag that into the Y. And in order to get that to be uniform, you can see that it's kind of just creating more of a rectangle, and that's because I need to have more in the U direction. I'm just going to give it a small expression. So I'm going to right click, go down to expression, do a little algebra, so X representing the input value, so 30 times 2 to double that. And now I've got more of a square grid of points. Using these different field forces, the denser the grid, the kind of more constricting it can be. So I usually try to deal with something that's pretty loose and not has a huge density of points. So something closer to that level. And I'm going to also go ahead and flatten these for now. So that's, again, just one giant grid of points. So we're going to start off using just a couple of point charges. So the way this works is that you create a random point in Rhino. So I'm going to place one right here. I'll create another one over here and then another one over there. And I'm going to give them different z values in relation to this giant field. Let's make this one a little bit further. And since I have 3, I actually want to use 3 unique functions. So let's just go ahead and reference one point for now. So set one point, place that there. Now we can start to assign a charge value. We want these to be significantly large, so I'm going to start off with like 1500. And I'm just going to copy and paste this. Set one point and use this one, and then copy and paste one more time, set this point. So now we actually have to put this together in a way to begin affecting our point of grids. There's a couple ways to do that. So vector, field, we can begin to merge the fields that way. Something I want to do, because if it's a little bit of a pain if you have a lot of these, you have to hold the shift to bring them all together, and if you want to ever disconnect, then it kind of affects the order. So one way you can do this is if you go to sets, tree, and merge. It's similar, but we still want to connect it. But this just allows us to have unique inputs. And every time we add one, it'll just automatically create another one. So this gives us a little more control over those inputs. So now I've got them all merged together. Now I'm going to go to vector and evaluate this field. So it's looking for that force and the points. This gives me a tensor, and we don't use that terminology in a lot of these, but if we look at the icon again, it's very similar to the move icon. So that's what we want to do, is say use these tensor directions to move these points. So move, I want to move my grid of points using these directions. And let's go ahead and turn this off. So now we can start to see our grid of points beginning to bubble up. So as I begin to move them, they'll start to affect it. This is that one, so I can, let's turn this off so it's a little bit easier to know which one I select, right? So there's this one. And so I'm going to just drag this number slider to create something more kind of rounded. If you start to bring that down and then really increase the value, it'll just create something a little more subtle. And so if it's below our grid of points, it'll start to bubble them up. If it's above it, it'll start to push those points down. So that's this one. So again, depending on that charge level, you can start to create all sorts of different undulations in your surface. So this is really just kind of creating a repulsion of, or propulsion of these points. The other thing you can do, so these all have positive values. If you want them to actually start to kind of attract to them, we can actually give them a negative value. So what if instead of this one pushing down, what if it starts to attract them up? So I'm going to double click inside of this, click on my minimum value and click negative 10,000. And okay. So now as I begin to drag this towards it into the negative values, you'll see that it starts to attract those points in a different type of way. So this actually, instead of it kind of having this rounded pushing away, it actually starts to kind of create more of a sharp attraction force, which is kind of interesting to create another kind of unique landform or mound in our surface. And then again, I can kind of start to push these away and start to do it. So like I said, it gives you a lot of flexibility and a lot of different ways to create some pretty interesting topography. So again, we've got a grid of points, but we actually need to have a surface coming out of this. So the next thing is that we want to take our points and create a surface from them. So let's turn this off. And so if I go to my surface, I have the ability to create a surface from points. So here's the points I want to use. Then it's asking for the number of points in the U direction. So keep that in mind. It's asking for number of points in the U direction. You would think that, okay, I've got my U count here, which is 16, but read what this is asking. It's saying number of segments in the U direction. So the number of segments is always going to be one less than the number of points, because you need 2 points to create one segment, 3 points to create 2 segments. So regardless of the number of segments, there's always going to be one additional point. And you really have to keep that in mind when doing this, because if you just use the same slider and expression, it's going to give you an error. So let's remember that. We have an expression of x times 2. So let's see what happens if I drag that into there. We can see that it just automatically jumps to red. Even if I go to expression and say x times 2, so that's the same expression. So I'm still saying a value or input of 16. You can see that it says 16. So this might create some immediate confusion, but if you actually give it another function to this expression, so x times 2 plus 1, so regardless of what that expression is, regardless of what that input is, if you always add 1, it'll solve that issue. Now you can see that I've got a solid surface coming out of this. So let's go ahead again and turn these off. And now I've got an actual surface coming out of this. And again, I can go ahead and bake this and say 1, and this is what our surface starts to look like. So it creates a more kind of softer surface type, something a little more gestural. Like I said, the less points, the better. If I start to really amp up these values, in this case, since I'm still only using 3, it doesn't look too rigid, but it does start to create a denser grid of points. You'll probably especially start to see something change in that part of it. Let's see. So as I reduce that, notice how the peak of this starts to become more and more defined. Obviously, eventually it's going to kind of maintain itself, but like I said, you can start to fluctuate that. And again, the more points, the more information it has. That could be good or bad. It really kind of depends. So you can see just what that density of points looks like in comparison. So let's move on to a different type of force. So I'll go ahead and just turn all this off. I don't need these points. All this is going to be completely different for the most part, except for this. Actually, I don't even need the surface divide for the next part, but I do have, again, my surface. But there is one more thing I want to add to this. So I'm going to just turn our surface back on, and I'm going to draw a curve at the lower end of this. So I also have this curve, which I'm not going to need immediately, but I will need it at one point. Now I'll just go ahead and hide this. So in order to use, and I'm going to hide these points too. So in order to get the spin forces to work, it's a little bit easier to use field lines to create that, and you'll see what exactly is meant by that. So these work really well by having a combination of a line charge or a vector charge in combination with our spin forces. And you'll see what I mean by that. So let's go ahead and create a line charge. So it's asking again for a line. It asks for a charge value. Let's see what the difference is between the vector force. So in this way, it's very similar. It's still asking for a line, but it's more, I personally like the vector force opposed to the line charge, because it's just a little bit less information to have to worry about. So if I just right click and say set one line, I can pretty much put this anywhere and in any direction, and that starts to create a designated direction. And let's go ahead and use this curve now, and I'm going to divide this by a series of points. So let's just start off with something like 30. All right, so I got 30 points. Let's go back to vector, fields, and we want to create field lines. Remember that. So there's the field to evaluate, which is this one. There's the points, which are these. And you can see that now I've kind of, depending on the length of this vector, it'll start to kind of dictate the length. So if I right click, say, set one line and do it slightly different direction and shorter distance. See what happens if I do it really minute. So it's a good way to kind of begin to control that. We can see what happens if I use this one. So the reason I don't like to use this is because now you have like a separate charge. In this case, it could be about the length, but let's see. So let's try it. Set one line. I'm going to do the same thing. you can already see that's kind of got a much different result. So that's why the vector kind of tells it a direction. You could also do it by changing the strength of that line. But for now, I think this should be okay. We can use our surface to create an immediate bounce for that. And that'll be good for one case, but let's actually, instead of just doing a planar surface, let's actually give it some volume, because for some of the next things, it's going to be good to have actually some height to this. So there's a couple different ways to add height to it in this instance, but let's go to surface, primitive, box rectangle. So here's my rectangle. I want to give it a domain for its height. So let's go to math, construct domain. I'm going to do something between -50 less than 0 less than 50. So this will give me the ability to give a negative direction and a positive value. So now I've actually got this kind of bounding box that way. And you'll see if I, again, put this into here, it's going to give me the same results because the lines don't have any z values, but you'll see how that's helpful later. So I'm just going to turn this off for now. So actually, let's start off with this bound. So the other one's a little more complicated, so to speak, but or it just adds a couple more extra steps. But let's just start off with something that's has some three-dimensional quality to it. So you'll see that this is just the field to evaluate, but like I said, we want to have multiple fields. So again, I'm going to go to Sets, Tree, Merge. So I want to merge this one with some spin forces. So let's just kind of move this one a little bit further. You can see that there's other things in this that we can start to adjust, but for now it should be okay. And again, I'll just kind of replace that one. And now I can start to add these spin forces. And it's very similar where instead of it just being a charge, essentially kind of a force field, it's now just gonna spin these curves in whatever that designated direction. So I'm going to, again, create some random points here, set one plane, or in this case I want to start off with a point. I'll show you where you can get a little more creative with this in the next step. So I've got this, I can start to play with the strength again. So let's do, I don't know if these have to be as powerful as those point charges, as you'll see. And then there's also a radius, which I'll give another kind of similar value. So that can be a little bit less. So now I can plug that into there, and you'll start to see how it begins to affect those curves. So like I said, I don't think we need to have a very powerful charge. The radius just kind of, like it suggests, affects it that way. So what's interesting as you work with this is that both the length, or this vector line, and these vector spins start to compete with each other. So let's see what happens if I do a slightly longer one. Usually those start to kind of dictate it. I've got it over in here. Let's just double check why it's not operating the way it should. Okay, so let's go back to this. So let's just try creating a line from SDL. So curve, line SDL, the start point is this point. Direction, I could always do it like this, set one vector. And then I can dictate the length that way. So let's try something like 25. And it's still not having as much. I think it might be because of the bounds. Let's try that. That helps clean it up. Let's go back to this one to again make sure everything's operating correctly. Did I merge them? I think that's the issue, right? So yeah, I didn't actually merge those forces. So let's go back to that vector, because now it's just kind of understanding one. So merge fields. Now I can drag it. Now we'll see a much different output. So again, this kind of, that starts to overpower my charge. There we go. So remember to merge, like you have to have these two merges. There's the actual merging of these, just inputs, and then there's actually combining those forces together. So now if I start to reduce that, you can start to see how they begin to compete with each other, which starts to create some interesting results. And let's continue to add some more of these. So again, I've got my 3D bounding box. Let's go ahead and do another point. And let's actually change the direction of the force. So again, I'm going to give this one a negative value. So let's do negative 100 as that other end. You'll see that as soon as I change into the negatives, the directions on this wheel change as well, right? So positive's going that direction, negative goes that direction. Now I can drag that into there, and we can start to see how this starts to affect it. And like I said, so if it's weak, then the length kind of takes over. If it doesn't, start to create some really interesting kind of like topography. So that starts to create a pretty interesting field of lines. But what's even more interesting, let's get rid of these for now. Like, let's actually give this some three-dimensional quality. So I'll keep those points there, but the purpose is I can right-click and say one plane, and I can, again, use that same location, but I can start to rotate it. So now it starts to create this kind of swirling down in different directions. So it creates these really kind of interesting, almost vortexes in your topography. And again, you can kind of play with how strong you want those things to be. How much are they going to do it for? Create some really interesting kind of almost whimsical types of topography. All right, so pretty interesting. But again, like how we create a surface from this is a little bit different. You would think that you could just begin to loft that, but it's a little bit it's not as simple as that. I would actually try to do it again from a similar approach as before, using a grid of points. So what I'm going to do is take those curves and divide them by a number of points. Okay? And so this is similar in the sense that we have a certain count in a different direction. So let's just give this a value so that way we can input it into the next one. And this gets a little bit tricky because you just have to remember kind of the order in which this data is placed. So I'm going to go to set surface again, surface from points, going to again flatten this, and let's see what happens if I drag this into there and give it an expression of x plus 1. It does give us a result, but that's not the one I was hoping for. So there's two different counts. There's the number of segments or points, and then there's also the number of curves. In this case, it's 31. So let's try something else. Let's get rid of this expression. So it's actually asking for, I think, the data going in the other direction, or the number of curves or points. So let's try this. And that's what actually gives us our result. So the number of points is obviously going to help us create the surface itself, but it doesn't need this value. This helps obviously with the quality of that surface, but for the U count, it's actually, again, it's the X direction. So we've got the number of points in the Y direction, but it's the curves in the X direction, or in other words, whatever this value is. So again, you could do it that way too, instead of using this length. But you'll have to remember it's the same kind of process of doing the U count of expression of x plus 1. And that'll give you the same result. And let's just see what this happens to look like once I bake it. Should be pretty interesting. Yeah, I would say so. So again, it's a very kind of whimsical surface. You can begin to trim some of that out, actually have it fit within your project parameters, but for now it's a really interesting result for a landform. Let's look at one more thing. So I'm going to go back to, let's go ahead and save this one and just copy and paste it. So this next one is the one that's a little bit more different, so to speak. So I'll again use these points. I'm not going to create a surface from here. I'm actually going to just go ahead and get rid of all of that. Let's turn all of this off. And do the same thing for the next one, but reference this. And let's see what these field lines look like. Let's see if that's what we want. Let's give our line a little more strength. Maybe this one's in a little bit further to kind of create this move there. Okay, I think I can live with this for now. Again, there's so many different ways of creating this that you can easily get lost, and hopefully this at least gives you enough to explore. So with these lines, I can actually start to say, you know what, I want them to just kind of move based off of a designated profile. So let's try that. Again, I've got 31 curves. I'm going to use my graph mapper to arrange them in different heights. So I'm going to, again, this one, I like to just stick with its existing domain and not really mess with any of these domain values in either the X or the Y direction. So I'm going to take this length of 31 and just remap it between a 0 and 1 domain. So let's go to sets, range. Domain is going to be from 0 to 1, and then the number is however many it's counting. So in this case 31, and you'll see that's again kind of creating an extra one, so you could do it that way, or you can just drag that into there. And again, I've got 31 as my range of numbers. So this is again kind of why we wanted to plug this into the points. Obviously we can always adjust that density. So I'm going to drag that into there. So this is going to work to move these points in the different direction. So let's go ahead and go to move. So geometry. Again, I want to move it in the Z direction. If I stick with whatever these outputs are between 0 and 1, it's not going to give us a lot of fluctuation. So I'm going to multiply these values by 30. And now I can turn this off. And now I can see where I'm creating some pretty interesting ridges and valleys and kind of like little plateaus. And it's the same thing as before. Let's just actually play with this a little bit more, right? So I can use this to kind of adjust where these different ripples go. I can adjust how smooth or how rigid it is, right? I can play with the scale of it. Play with the heights that way to kind of exaggerate it. Either way, I've got an interesting surface. And it's the same thing as before, where I can now divide these by something like 15. Go to surface, to surface from points. I'm going to flatten this. And again, the U count should be the same as this number plus 1. So this expression, x plus 1, and now we've got this awesome surface. Okay. So again, and what's good about it is I can always begin to adjust this. You can see how it kind of creates this interesting wave effect. Play with how kind of rigid it becomes, right? So the more of these kind of pitches, the more of these same kind of ripples occur. So all sorts of different outcomes, and that's just from that graph map, but we can change the density of the points. It doesn't look like it's doing too much, but we can always continue to play with our different forces, right? So I've got some small ones, some large ones. Let's see, it kind of helps seeing the actual lines, right? So if it's a little bit weaker, that helps kind of enclose that. How big it is can start to affect it. So it's again something I like to have a lot of fun with creating some pretty interesting landforms that way. So again, kind of. Right, so there you go. So this is a kind of primer for using these forces, whether they're point charges or spin forces, in combination with the vector. So again, if I want to play with the direction, so set one vector, maybe I want it to go in the other direction, and and you immediately have a different outcome. Like I said, it's easy to get lost with all the different options, but again, create some pretty interesting results.